Hello, wonderful algebra students. This is going to be a lesson summary video on our first lesson from Unit 1. Unit 1 is going to be all about equations, linear equations, and the first lesson we looked at in class today was called Planning a Pizza Party. Now, this video isn't going to be a video of the entire lesson, but the hope is that this video will be a good summary video for you to help you synthesize and really cement in all of that learning and the math concepts we covered in this lesson. The first major math concept that we introduced in this lesson is the idea of a mathematical model. This is a fancy math word for what we've spent already a lot of time in pre-algebra really working on, being able to represent real-life situations using math expressions, equations, and inequalities. Now, I mentioned this is something that we were working on throughout pre-algebra, and we're going to continue to work on this throughout algebra as well. A huge part of being a mathematician is being able to create and interpret these mathematical models. Now, below I've got what was the warm-up from today's lesson, which I think is a great introduction to what we're talking about when we talk about mathematical models. The warm-up gave us these 4 letters or variables below and tells us what each of those represents. And when we're talking about cost in this problem here, the cost is in dollars. So M, we're given, represents the cost of a main dish. N represents the number of side dishes. S represents the cost of a side dish. And T represents the total cost of a meal. The goal from this question was to be able to put into our own words what each of these equations below mean in this situation. When we're describing these equations, really try to push yourself to put it into like everyday words, as opposed to it being like very like math class sounding. So just think about like how you would describe the situation outside of math class. I would really encourage you, if you haven't already attempted this problem, to pause this video now and try to explain in your own words what these 4 equations are. Take as much time as you need to do that, and then come back to see what those answers are. Alrighty. So for this first one, we are told that m equals 7.5. For this problem, and I think for any situation, honestly, where it's using a variable, as soon as I see that letter, I want to refer back to what that letter is talking about. So when I see the letter M, I'm going to immediately jump back up here and remind myself of what M represents. M represents the cost of a main dish. So when we say M equals 7.50, what that's really saying is that the cost of a main dish equals, or I could just say is, $7.50. Now, as we go down this list, there's a little more to these last 3 equations where we've got some operations in them. When I look at equation B, it says m equals s plus 4.50. Again, when I see those variables, I want to jump back to this top part and see what they're talking about. So for M, we've got M again is the cost of that main dish. And then S, we are told S is the cost of a side dish. So if I'm looking at this equation, the equation as it's written is telling us the cost of a main dish equals the cost of a side dish plus $4.50. Now, when I talked about earlier, really pushing yourself to say this in everyday words, right now what I've got in front of me is, it sounds like a math equation. It doesn't sound like everyday words. When we're saying the main dish equals the side dish plus $4.50, try to think about what that really means. We're talking about 2 variables now, so thinking about how you could compare those 2 costs. Is this equation telling me the main dish is more expensive or the side dish is more expensive? How much more expensive? Think about it that way, and we can change this right here into something that sounds a little more everyday, and it makes more sense to us. So when we're saying the main dish equals the side dish plus $4.50, that's telling me that the main dish is more expensive. The main dish is the cost of the main dish, I should say, is the same as the side dish plus $4.50. So what that equation is telling me is the cost of a main dish is $4.50 more than the side dish. If I go back to that equation, my main dish is whatever that side dish is plus $4.50 because it's $4.50 more. This would be a stronger interpretation because now I'm really understanding that comparison here. For the next one, we've got NS equals 6. Again, I see two variables, so I'm going to come back up to the top here. N is going to be the number of side dishes, and S is the cost of a side dish. Again, we could write this out exactly as what it says. So what I mean by that is we've got the number of side dishes, and then if NS is next to each other like that, it means multiplication. So I could write the number of side dishes times the cost of a side dish is 6. But again, that sounds like a math equation. It doesn't sound like something I would say outside of math class. So to push yourself, think about why we would want to multiply the number of side dishes by the cost of a side dish. What are you figuring out by doing this math right here? By multiplying the number of sides you get times the cost of a side dish. Well, by doing that multiplication, you're figuring out the total cost of the side dishes. You multiply how many sides you're getting times the cost of each one. That's getting you the total cost of the sides. So I'm going to adjust this a little bit to say the total cost of the side dishes is, and then let me throw in a dollar sign here. The total cost of the side dishes is $6. That's really that strong interpretation we're looking for and pushing us towards. There's one last one. This one might look a little crazy too because there's so many variables in here, but we can use all of those things from earlier that we had come up with. M, I know is the cost of my main dish. NS, we just said is the total cost of the side dishes. So when we put this all together, we've got the cost of a main dish plus the total cost of the side dishes equals T. Then you might be able to guess, even without coming up here, it equals the total cost of the meal. So we get those 4 interpretations there. This lesson today introduced this idea of interpreting these mathematical models, or in this case, these equations. And then we're also going to be working on coming up with these models ourselves. So being able to write equations, inequalities, expressions, whatever it might be for the situation. This is something we introduced in this lesson, but we are going to be practicing this throughout the entire unit. So this was just an introduction and a preview of what's more to come. This was the first concept we were really working to introduce in this lesson. The other major concept is this one right here, this word constraint. Now, if you're coming from our pre-algebra class, this is not something we've talked about yet, but it's something we're going to use a lot in this unit and in future units. A constraint is a limitation on what is possible or reasonable in a situation. When we are talking about situations, especially situations where we're using variables, every number in the world isn't always a possibility for that situation. And to help explain what I mean by that, we're going to use this idea here of planning a birthday party to help us talk about constraints. So when we are planning a birthday party, we might be dealing with a lot of different quantities. There's some examples listed below, like the number of guests, the cost of food and drinks, the cost of a birthday cake, entertainment, that total cost. There's a lot of different quantities there. When you're thinking of something like the number of guests who come to that birthday party, every single number we have in the world isn't a possibility when you're talking about the number of guests. We might put a constraint or a limitation on the number of guests For example, to say at this birthday party, there's going to be a maximum of 20 people or no more than 20 people. That's a constraint. We're limiting how many people can come to that party. There's examples of other constraints for these other quantities. So for example, when you're talking about how much you're spending per person, we might say, I'm going to spend $5.50 per person. That's another constraint. If you're buying $40 for a large cake, that's a constraint. If we say you're going to spend no more than $180 for that total cost of the party, those are all examples of constraints. Now, right now, I've got all of these constraints written out in everyday words. It's not in math terms yet. But we can change all these constraints into mathematical models, meaning we can represent all of these constraints using expressions, equations, inequalities, math, basically. So when we talk about representing constraints in algebra, you can use both numbers and letters or variables to represent those constraints. You can use expressions. So it doesn't necessarily have to have an equal sign or an inequality sign. You can just write 40 for the cost of that large cake. But if you are given a little more information, you can always use inequalities like less than and greater than, or an equation using an equal sign to help you represent those constraints as well. So continuing on with this example here, with these 5 constraints, I'm going to have you go ahead, pause this video now and try number 1. And number 1 is asking you, how could you represent each of these constraints above using a mathematical model? Or in other words, how could you represent all of these constraints using math? Using numbers, variables, expressions, equations, inequalities, whatever seems right for that particular constraint. Go ahead, pause the video and try that now. So I'm going to go through them one at a time and you can check to see how you did. For that constraint of 20 people maximum, that word maximum or minimum or there's no more than 20 people, all of that language is giving me a clue that an inequality is going to be best to represent this. I might use P to represent the number of people. And if I want to say the number of people is a maximum of 20 people, that means the number of people needs to be less than 20 or equal to 20. It's hard for me to write that less than or equal sign with a keyboard, so I write less than or equal like that. But please know that the official symbol looks like this. So we would want to say P is less than or equal to 20. When we're thinking about numbers, P could be here too. You might also see a description of what type of numbers are possible. We might also say that P has to be whole numbers. And if that word whole numbers is new to you, whole numbers means not decimals and fractions. Whole numbers are those like counting numbers you learn when you first start doing numbers as a kid, like 0, 1, 2, 3. If I'm talking about people, I can't have 5.5 people at my party, right? So you might also see the constraint specified that it has to be whole numbers. That next one, when we're saying it's $5.50 per person, $5.50 per person, well, I'm using P as the number of people. So I might want to say I need to spend $5.50 times the number of people I invite. So 550p. This first one was an example of an inequality. This next one here is an example of an expression. It's not an equal, there's no equal to or no inequality sign, so it's not an equation or inequality. That's right there is an example of an expression. When we say when we say $40 for a large cake, that's an example of something where I know that exact value. I could just represent that with 40. I'm going to spend $40 for that cake. Same for the 15 for music and 27 for games. If that represents our total entertainment, I could represent my entertainment with 15 plus 27. 15 for the music, 27 for the games. Or if you actually did that math to figure out that total cost of entertainment, you could also say 42. And then that last one, we've got that language again, no more than $180 for that total cost. So that would be a clue for another inequality we're going to use here. If I want to spend no more than $180, that one I'm going to represent as my total cost. Maybe I'll use T here. My total cost needs to be less than 180 because I want to spend no more than 180. No more than 180 also is including 180. So I want to spend less than $180 or equal to $180, just not greater than 180. And again, it's easiest for me to type it like that. And on your homework, that's how you would need to type it. But please know that that official symbol looks like that. So it would be T is less than 180. These are all examples of mathematical models, specifically the constraints that we're trying to describe in these situations here. So to summarize this, in the purpose of mathematical models and constraints, we've got this quick summary here. If you want to pause the video now to read through it, you can. But basically, it's saying we can use all of this math to help us represent these limitations for our problems. Notice that all of these mathematical models I wrote for these constraints, p is less than or equal to 20, 5.50 p, 42, those are a lot simpler and more concise than all of these written descriptions. So these mathematical models and constraints help us very efficiently communicate what that limitation is. Once we've got all of these here too, we can also come up with other mathematical models like equations that help us represent the problem further. So for example, if you look right here with these equations, once I've got that I'm spending $5.50 per person and $40 for the cake and $42 for entertainment, I can put those all together to come up with one equation for that total cost. The main purpose of why we've got all of these, though, is that it's very efficient as far as communicating. And then the day of the party, if I know the number of people who come is 10, this gives me a really easy way to help me figure out what that total cost is going to be. I just have to do that 550 times my 10 people and add an 82 instead of having to come back up here and do all of this math again. The goal of math is not to be complicated. It's literally the opposite. It's to help us be efficient and clearly communicating and to help make those calculations easier for future us. So as a reminder, these are things we're going to be working on throughout this entire unit. When you get to the homework is going to have us start practicing coming up with some of these mathematical models from situations and identifying constraints. To give you an opportunity to practice that, I've got this really fun one here with fractions involved. The situation we're looking at here is the Doors Student Leadership Committee is holding a fundraiser. Their goal is to raise T dollars and to donate to a cat shelter or a dog shelter. They ask N students for donations. Our goal is to match each quantity to the expression, equation, or inequality that describes it. So below, we've got 6 different situations here that are describing that constraint. And then we've got the 6 mathematical models. I see some expressions, an inequality, an equation. Our goal is to match each of these descriptions to the correct mathematical model, basically to the correct math problem. I'm going to scroll up real quick because I can't get it all on my screen at once, but to remind you of the 2 main things, we are given 2 variables here. T, we're told, is that total money they're trying to raise, and N is the number of students they ask for donations from. And they're getting donations for a cat shelter and a dog shelter, so that money's going to different places. I'm going to scroll back down again. I would strongly encourage you to pause the video now. Try to see how many of these you can match up on your own. The best way to learn stuff is to be a part of the learning. So if you pause this video and give yourself a chance to practice, that's really going to help you in the long run. Once you've tried your best at matching these up, come back to the video to see what those correct matches would be. Alrighty, so this first one is telling us the dollar amount the club would have if they reach 1/4 of their goal. Well, we were told earlier that their goal is $T, so I want to find the one, and I'll write this out in words real quick. We're looking for 1/4 of their goal, and we know their goal is T, so we're looking for 1/4 of T. That is going to be right here. So A is going to match with that third expression, 1/4 T. The second one is saying their goal is to raise at least $50. Again, when I see that word, their goal, we know the goal is at least $50. And the goal, I know that goal money we're representing with T. So I might think of it as T is at least $50. That phrase at least can be tricky when we're saying at least. Means the money we want them to make, we want it to be more than 50 or equal to 50. Least is such a tricky word, I think, because I see the word least and you might think less. But if you say I want at least $50, you're saying you want $50 or more. And I see that right here. It's that fourth one. Their goal is to get more than or equal to $50. For C, we've got the dollar amount the club would have if each student donates a quarter. Now, you might be looking at this, and that word quarter might stump you a little bit, because I know a quarter is 25 cents, but when I look over here, I don't see any 25 cents. So I think the challenge with part C here is a quarter we know is 0.25, but there's another way you can represent a quarter, and that is 1/4. A quarter is 1/4 of a dollar. 0.25 is equal to 1/4. Another way you can say 1/4 is 1/4 too. So we have to think of a quarter with 1/4 because that's how it's going to be represented over here. So when we're saying the dollar amount the club would have if each student donates a quarter, well, for students who are donating, we were representing that with N. So N students give 1/4 of a dollar. That would be N times that 1/4 of a dollar for that total amount of money. And I see that up here. So C is going with this one right here. 1/4 of a dollar times N students who donate 1/4 of a dollar. There's 3 left. D says they ask a total of 50 students to donate. Well, the number of students, we've been representing that with N. So we're told that N students is a total of 50 students. So N equals 50. And I see that right down there at the bottom. 50 equals N and N equals 50 are the same things. That leaves us with 2 last ones here. For E, we're told the dollar amount they would have if half the students they ask donate a quarter. Now there's 2 numbers going on here. We've got half of the students. Well, we've been representing the number of students with the letter N. So half of the students would be half of N. So half N represents the half of students, and half the students donate a quarter. Now we talked about earlier, a quarter in this problem we're representing with a fraction 1/4. So half of the students each give 1/4 of a dollar. Half of students give 1/4 of a dollar. If half of our students are giving 1/4 of a dollar, I'm going to multiply those together to figure out how much total money they're getting. So I'm looking for half N times 1/4 of a dollar, and I see that right across. So E goes with that 5th one there. There's only one left. So that means F must be going with this one up here. We still definitely want to check to make sure we agree with that because, we don't want to make a mistake on one of these earlier ones. This last one here says the dollar amount they would have left to donate to the cat shelter if they give 1/4 of their money to the dog shelter. We were told at the beginning that, remember, they're donating their money two places. So we're told they gave 1/4 of their money to the dog shelter. For this one, I might think of it with a picture actually. So if this circle right here represents that total money they have, they've split that total money they have into 4 parts. And one of those 4 parts, represent it with this purple squiggle here, 1/4 of that money is going to the dog shelter. So 1/4, that purple little sliver right there, is going to the dogs. The question is, how much money would be left to donate to the cat shelter? Well, if they donated 1/4 of their money to the dog shelter, that's going to leave 3/4 of their money for the cat shelter. So I'm going to write that out. 3/4 of the total money for cats. So I'm looking for that expression that represents 3/4 of the total money. I see that up there, 3/4 of the total money, which is why F matches with 3/4 T. I think this one is definitely a little more challenging because it's got all this fun fraction stuff here. The homework isn't going to be all fractions, but I definitely thought this would be a good one to practice since, let's be honest, I know fractions aren't always everyone's favorite thing to do. There's going to be lots more opportunities in this unit to practice stuff like this, to practice mathematical models, matching, and being able to interpret mathematical models and coming up with these constraints. This first lesson here was just an introduction to it, and it's going to be something we practice for the next couple weeks. I hope you found this lesson summary video helpful, and I will see you all back tomorrow for the next lesson. Bye, guys.